Imagine for a second a world where the code is the only source of truth. Not just a guideline, not an approximation, but the absolute final law. That is the wild idea behind the Hyperverse TTC, and it's what we're digging into today. It's a system where if the code doesn't do it, it just isn't real.
All right, so let's get right into it. The very heart of this TTC framework is a philosophy called Runtime Law. Now, this isn't just a best practice for developers. You can think of it as the constitution for the entire system. It sets up a really clear, really strict chain of command.
And this quote, this is the core belief. So what does replayable runtime behavior actually mean? Well, it means the only thing that counts as true is something you can prove by rerunning the code and getting the exact same result, bit for bit. If you can't replay it perfectly, it's not the truth. It's just commentary.
Now, just think about that for a moment. I mean, we've all been there, right? You're looking at a system diagram that doesn't match reality, or reading code comments that are hopelessly out of date. Documentation that promises one thing while the code does something totally different. This whole system is built to make that kind of confusion impossible.
So, and this is the crucial part, this is enforced as an absolute law. If there's a fight between a beautifully written paragraph explaining a feature and what the executable code actually does, the code wins. Every single time. No exceptions. The text has to be corrected because the runtime is, by definition, never wrong.
So how do you even enforce a rule that strict? Well, the system has a set of constitutional laws. And these aren't just technical rules, they're more like a statement of values. They spell out exactly what the system has to prioritize and, just as importantly, what it has to ignore.
And this slide, wow, this really spells it out, doesn't it? On one side, you have everything the system must preserve, things that are mathematically provable, like determinism and replayability. On the other side, everything it's forbidden from caring about. Notice things like prettier narrative or easier metaphors. The goal here is brutally honest, verifiable truth, not a comforting story.
And here's that power structure in action. It's a strict hierarchy. At the very top, the runtime truth beats any explanation. The actual data types are more important than how you visualize them. The ability to replay the code is more important than what you call a file. In every single case, the verifiable behavior always wins against the human-friendly labels and descriptions.
So how does this all fit together in practice? Well, the whole architecture is built on a stack of layers, and each layer has a very specific, strictly defined level of authority. Information can only flow from the core, most authoritative layer outwards to the least authoritative ones. And here's a map of that power structure. It all starts at the top with runtime. It's listed as sovereign, it's the king. Everything else is derived from it. But look all the way down near the bottom. That's where projection lives. It has basically no authority at all. It's just a representation of truths that were decided way higher up the food chain.
Let's be clear about the runtime layer. It is the absolute monarch. It is the official, undeniable history of everything that has ever happened in the system. It is the one and the only source of truth. Any question about what the system is or what it did gets answered right here by replaying the code. Period. And then you have the projection layer. This is everything we humans use to see the data. You know, JSON files, ASCII diagrams, web pages, user interfaces. The system says these things are useful, sure, maybe even necessary, but they have zero power. They're just a window into the world. They're not the world itself.
Okay, so let's bring this down to earth with a perfect practical example, a user interface. How could you build, say, a web portal that perfectly follows this philosophy of having zero authority? How do you guarantee that what you're seeing on your screen is the absolute, untainted truth? The core idea is actually pretty simple, but it's incredibly powerful. The UI is just a view. It's a mirror. It can reflect the source of truth perfectly, but it can never, ever change what it's reflecting. It's a passive observer, which makes it totally trustworthy. And the TTC framework actually shows us how this works with 3 different browser demos. One is totally static, like a frozen snapshot of the data. The other 2 are more interesting. They consume streams of data directly from the runtime. One reads from a file, and another gets a live feed. But in all 3 cases, the UI is just painting a picture based on data that was created somewhere else. It doesn't interpret anything, it just displays. And this quote from the project's own documents just sums it up perfectly. The user interfaces are schema consumers, not schema definers. That means they only receive and display information. They have no power to create or define it. And that creates an incredibly robust, reliable interface because what you see is guaranteed to be a direct reflection of what's real. So you're probably asking, why go to all this trouble, right? Why build a system with such intense, almost obsessive rules? And the answer comes down to one thing: the quest for perfect, verifiable trust. Why be so militant about this separation? Why build a wall between the one true reality of the runtime and all the different ways we might look at it? Because in some systems, a little bit of ambiguity isn't just an inconvenience, it's a complete catastrophe. And I want you to think about what kinds of systems absolutely cannot afford to be ambiguous. We're talking about financial systems where every single transaction has to be perfectly auditable, digital voting systems where every vote must be verifiably counted beyond any shadow of a doubt, or the control systems for a power grid or a water treatment plant. In these places, you need a single deterministic source of truth. You need runtime law. And that kind of leaves us with a final big question to think about. Look, this framework is an extreme solution for sure, but it forces us to ask something really important. As more and more of our world is built on and run by code, what is the real cost of a comment that lies, or a diagram that's wrong? What is the true cost of ambiguity?